Hello all, this is my homework for Paul McWhorter's AI for Everyone, Lesson 16. I will leave a link on this one to a location where you can see and download the code. It'll be in a Google Doc. So this was pretty straightforward in terms of once you've worked through the lesson with Paul, you have 98% of what you need to do the lesson. The only thing that made me scratch my head was how exactly do I use the things I learned in lesson 16 with a frame, and so we'll talk about that as we go through. So I've did some pretty extensive commenting on this. I like to do that just to help me remember where things are, what's going on as I go through it. So we import the operating system, and since we're going to put measurements of the frames per second on the frame, we need to have time. We also import CV2 so we can have all of those functions. And there's another library called face recognition, and we implement that as FR just because it's tough to go ahead and type in face_recognition all the time. We set up variables for font, width, and height. The very upper left, which is the location where we're going to put the frames per second, define some colors, and then we have a height one and a thickness one for our various fonts. Since we're going to be doing a video capture, we want to get everything set up for that, and we call it cam. And so then we set up the library tools to load a known image file to train the program for locating other faces. In this case for me, I call it me face instead of Don or Nancy or Pence face, and I load in an image which is a recent image of me sitting here at the computer, just so I can have good luck and make it easy for the program to train and find a face. I set up a variable called face location, and that make that equal to the face or frame recognition dot or fr dot face locations, and it searches the me face, and when it finds it in the array, it stops. So it's going to find it, since it's the only face there, it's going to use that location. So then I encode that to get the information and location of where the face is. Then I did the same thing with an Einstein face location and encoding. Then I create a known encodings array, which is me face and Einstein face. I create an array of names, which is me and Albert, and then begin a while true loop. Set the frames per second to 10 so it has something to calculate on the first time through, and then we do a cam read. Now, if you followed through lesson 16 with Paul, he named the unknown face image as unknown face, so we don't have to change any names or anything. We just do a cam read and call it unknown face. That's one frame each time we go through the while true loop. So then we convert it from the RGB to BGR, which is what CVT color likes to use, or CVT2 likes to use. Then we find in or assign any face locations to unknown faces RGB, unknown face RGB. We create a code encoding for unknown face RGB, and include face locations. We set a name. I called it unknown person because that's who I'm looking to see if there are any unknown persons. And so then I go through a face location and encoding in zip fashions or unknown encodings. We start the time for the loop. We assign the locations of the face locations, and then we assign top, right, bottom, and left, which are returned by the face location. And so and then we create a rectangle and put it on the unknown face frame at left and top, and I said -10 for the top and +10 for the bottom, so it made the rectangle a little longer than just grabbing exactly on the face. Then we compare faces, and we go through the compare routine and find any faces in known encodings, and unknown encoding is where we assign them to. So if we find a true, which is what compare faces does, then we have matches. And so the match index is equal to match index of true. So wherever you find a true, you call out the match index, the index of the match index, and then we assign names to whatever that index is. So it'll be either, the name is going to be the name if it found one in our known face that we loaded and created face location and encodings for, or it's going to say nothing, and as we go through the loop, it's going to be unknown person unless there is a match. That's what this true statement accomplishes. I left in a line that we used in the lesson about using the CVT put text function, but basically I created another line so it would be right at the outside of the if true, and it would put a name on the unknown face frame at these locations. Then I called the rest of the timer loop to create frames per second, and then I put the text associated with the unknown face in blue at these locations, which were in the variables I created at the top of the program. Then I show the frame unknown face and wait for a Q press to quit. And then of course release the cam, destroy all windows, and then because I don't like the terminal being left just dangling in the way, I like to call the system to clear it. The system command on a Windows system is CLS, that clears the terminal screen. So I'm going to go ahead and run that for you. Oh, I guess I'll have to Alt-Tab because I changed things up here. So as you can see, it'll detect me, it'll detect Albert, it doesn't detect me, and it can't detect Albert now. You can see the frames per second is pretty steady. If we're doing a look at two faces, then we have a bouncing between 8 and 9 frames per second. And you can see my cat, her name is Fox. She likes to invade when I'm doing these sorts of things. I'll post a link to where Paul's lesson is associated in the description of this video, along with that link as to where you can get my code. If you have questions, feel free to ask them. I try to respond as I can. I'm going to press Q now and exit the program. And you can see it cleans up the terminal screen. Thanks, have a good day.